Good day from Chem Help ASAP. We're going to talk about a different situation in which we encounter stereochemistry, and that's in alkenes. Now, I think alkenes are kind of surprising because when we think of stereochemistry, when I think of stereochemistry, I always instinctively look for an sp3 hybridized carbon with 4 different substituents. But alkenes are not sp3 hybridized carbons with 4 substituents. So let's see how this problem arises and then how we're going to address it as a stereochemical issue. So I have 2 alkenes written on the screen, and they are really similar. These are isomers of each other, but they're not constitutional isomers because all the atoms are bonded in the same way. So if we name these 2 structures, these are both alkenes, so we start the numbering at the highest priority functional group, the alkene, 1, 2, 3, there's some kind of propane, except it's an alkene, it's a propene, and we have a bromo with the 1 position, 1 bromopropene. If we go through the same line of thinking, the molecule on the right, we get the same name. And this is a problem. Molecules can't be different if they have the same name. And these are not the same molecules. How do we know they're not the same? Well, molecules that aren't the same are non-superimposable. And these are not superimposable. Furthermore, if we think about this in our language of stereoisomers, these are non-mirror images. They are not mirror images. Well, there's one type of stereoisomer that we've learned about that falls in the category of non-superimposable, non-mirror images. These are diastereomers. Now, it feels odd to me to talk about stereoisomers without having an sp3 hybridized carbon with 4 different substituents, but it's possible, and with alkenes, it happens pretty frequently. So now we have this problem. We recognize our different molecules. How do we name these? Well, we use the Cahn-Ingold-Prelog rules to name these, and we apply them a little bit differently, but what we do is we chop this double bond in half in an imaginary sense, and then we look at the groups on the left-hand carbon, carbon 1, and we give them priorities according to Cahn-Ingold-Prelog. So bromine is higher priority than hydrogen because bromine has a higher atomic number. This carbon, I'm going to mark out that 3, this carbon is higher priority than the hydrogen. And so now we have 2 high priority groups on either carbon. To get to them, we have to go through our double bond. We have to crisscross the double bond. Now, in German, there's this word entgegen, which means opposite or against. Our top priority groups are opposite each other across the double bond. Therefore, the symbol we use for this is not an R or an S. It's going to be an E, a letter E, and that's short for entgegen. So this would actually be called E 1-bromopropene. And that tells the reader how to set up the configuration of that particular alkene. Now in our other one, let's look at our other one, chop the double bond in half. We're going to do the same thing. Bromine is higher priority than hydrogen. Carbon, mark out that 3, is higher priority than hydrogen. Now our high priority groups are together. The word in German for together is zusammen. So letter Z is a symbol there. I had a friend who used to say Z is if groups are on the same side. So that's a little bit of humor for you. Z 1-bromopropene. So we do encounter frequently stereochemistry in alkenes, and so we need a way to discuss these alkenes. They're diastereomers of each other, and we use this easy nomenclature tool to distinguish between these 2 stereoisomers.